Hey everybody, this is Larry. This is August 1st. Oh no, is it? Well, it is August 1st here, but I think this is day 2 of the August Leetcode Daily Challenge. So hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem as soon as it wants to load for me. Do. Hope everyone's doing alright. Today I have not done my marathon training yet, my running training, or just training in general. So I'm trying to do this and then go out because it's still very hot. It's about 85 degrees here in New York City, Fahrenheit. What is that, like 30 degrees almost? So it's gonna be tough, but you have to do what you have to do. 87 days toward the marathon, I think, give or take a day. So I'm very pumped, very excited, but also very tired. So hopefully, right now I'm not tired because I haven't done the run yet. So hopefully this will kind of let me get there. But yeah. All right, let's go. Let's spin this. 2134 minimum swaps to group all ones together too. Is this the same as the one that we've done? I don't know. A swap is defined as two distinct positions. Have it? Yeah, I don't know. That's weird. Like we did this this week. Oh, it's a circular array. Okay, so a swap is we have a circular array. You have a binary circular array. You want to swap so that all the ones are together. Oh, this is just like a weird thing, weird explanation. Okay, so you have this, you have one, right? Okay. So it is similar to the problem that we did. Was it yesterday? No, but there was a problem where we did the sweep line A and B thing, right? There are a few variations of it, but I guess this is similar to that one. But yeah, n is 10 to the 5th, so yeah, it's just double checking that we cannot do n square. I don't know if we need to do n square, but it is a good thing to always check. Well, I mean, we can't now, right? So yeah. Okay, how do I want to think about this? The ways that I'm thinking about it right now, honestly, I don't have an idea immediately, but or at least I don't have the solution immediately. The idea that I have is just the same as the other one that we talked about the other day. You should watch my YouTube from like 2 or 3 days ago. I forget. It's not even in the same month, even though it was early in the week, so I don't remember what it is. So maybe, but it's just like the one about grouping A's and B's together. So definitely check that video out. I think it's from like 2 or 3 days ago. I made detailed drawings to kind of get an understanding. But for this one, okay, I see, I get it. Okay, I think the idea here is just to put them together, right? So let me actually bring up the drawing board. I think I get it. It's not that bad. I think I was just stuck a little bit on trying to think about it in terms of sliding window, right? Because so so I'm just bringing up the drawing things. Yeah. So basically, I'm going to do a very, very, very quick intro about the other one. So the other one that we talked about, it's A's and B's. So you have, A, B, A, B, A. And the way that we kind of talked about it, about just converting all the A's and converting everything to B's, right? By using a sweep line that does complexity, right? So that's basically the other problem. But here, I think it's not quite a similar idea, but it is. I think you just have to kind of think about the problem in a different way. Where here, but it is brute force in the same idea, right? So here we have like 0, 1, 0. What is it? 1, 1, 0, right? So then. No, I think that idea wasn't quite right. But oops. So I think Let's say what is going on with this thing? Okay. So I think the idea. I was for a second I thought it was going to be sliding windows, but then I was like, that doesn't make sense because it's not just about the number of zeros inside or whatever the window, right? It's not sliding window, or at least not in that way. Okay, so then the question is, okay, so let's say there are, let's say this is not a circular array, right? So we don't have to worry about the circularness of it. You know, we don't have to worry about any of this yet, right? Let's say this is just a regular array and you can only do swaps with adjacent, right? Then how would you think about this? Well, the answer I think is actually surprisingly straightforward, maybe. I mean, I think you have to figure out how to prove it, maybe a little bit, but yeah. But the idea here is that, for example, for this one, I'm just trying to find a different example because I think this example is a little bit too easy. But for example, here, the first one is going to be here, and it goes all the way to here, right? So then what is the cost of grouping the ones, which is also another way of saying getting rid of the zeros, right? Well, in this case, you have 1 0 that you can just move one outside, right? So then now that is just one cost, right? So that's basically kind of the idea, and then you have I'm just trying to look at example 2. Sorry. And then a secondary idea is also something like this, right? So then here, you know, this takes 2 moves. Wait, let me double check real quick. Oh, okay. I was wondering why I'm doing it wrong, but then the actual example solution is because it is circular, right? So, am I reading this wrong though? Let's see. What is one swap again? Maybe I misunderstood what swap means. Oh, I am dumb. Okay. Give me a second. I have to reset. I misread the problem. I thought. It's kind of weird. People, I don't know that people always use swap in this way, but maybe they. I mean, I guess they do. I think I just read it wrong. Sorry, my bad. Yeah, my bad. I mean, the idea is actually the same. It's just that the cost function is different, actually. But now I feel a little bit terrible. But okay. So the idea here is just that. The idea here, then, right? Okay, then I said some untrue things because I misread the prompt. So my apologies. Especially if you're watching this far and or if you skipped ahead because you found the beginning confusing. I thought that you could only swap adjacent numbers, so that's why my things were wrong. But then reading example 2, I was like, I don't get it. But it turns out that you can swap any 2 elements, right? So yeah, so then now because you can swap any 2 elements, it actually is sliding window. So this is where I said the untrue thing. And the reason why this is sliding window is that, okay, first you count all the number of ones, and in this case there are 5 of them, right? So then what happens is that now we can just look at a sliding window of width 5. And because of this, every 0 that is not inside, every 0 that we have inside, we know that there's going to be a 1 outside because we counted beforehand. So that means that we can just do 1 swap to make it optimal. So then here we have two zeros. So then here that means that the cost is going to be 2. And then we just kind of do the sliding window thing, right, of doing the next thing. And of course, as this is sliding window, we just get rid of one of the ones, and then we in this case anyway, we replace it with a 1, so we're good. But you know, this is just sliding window thing, and here we don't consider, we reuse the work we do for the middle 4, which is how we're able to get this in fast enough. This is pretty straightforward, right? I think one more thing that we would have to consider, just in case, is the circularness. And the circularness should not change anything. I mean, I know that I usually do this trick with doubling the arrays. I'm not going to talk about it because I don't think you need it for this one. So I'm not going to do it. But yeah, okay. So it's just sliding window. My fault. I misread this problem because I thought it was adjacent for some reason. I think I saw this adjacent and I think it just confused me or something. But yeah, okay. So then now maybe we have 1's is equal to nums.count1, right? So this is just the number of 1's inside the array, and we have the best is equal to number of swaps, and the best number of swaps is just going to be, in this case, 1, right? I mean, it can actually be that because by definition, at least one of the things doesn't move, right? Just you could probably prove that, but or at least like you could do 1's minus 1, I guess, but it doesn't. It's fine. It's just a worst case scenario. And then now we have a sliding window, right? So then here we do for I in range, right? And this is just going to be let's say the right side, right? And then left is equal to, in this case, is a sliding window. It's just right minus the number of 1's, right? Yeah. And then here, and maybe we also keep track of 1's inside the window, right? Is equal to 0. So then now we add the right side to the angle. So if num sub right is greater than or is equal to 1, then we increment the number of 1's. Otherwise, the left side is going to be right minus the number of 1's, right? So if left is greater than equal to 0, meaning if it's still, the left side we don't want it to go over. I think this is a little bit awkward the way that I'm setting it up because usually I don't have to set it up this way. This is why sometimes people do the doubling the array thing, but I am not doing the double array thing, so you have to be a little bit more careful. So then, 1's inside. For right in range of 1's, right? So this now gives us the first prefix, right? Here. So this is just keeping track of the right side. No, this isn't right. This is awkward. Yeah, I think, I mean, it's fine, but it's a little bit more awkward than I would like that to explain. And I'm trying to do it without the doubling the array thing. But yeah, but maybe actually what I want is I want the left side, right? So then now we want to start it off in range of 1's. Maybe 1's minus 1 actually, I think, because it takes the first 1's element, right? So then here, yeah. And you could write this in a more succinct way, but yeah. So then now, this is the setup for left is equal to 0, because this is when left is equal to -1, I suppose, like in the beginning. That's how it gets up. So left is equal to 0, so then left plus 1's, right? So if nums of this is equal to 1, then 1's inside, we increment by 1. And then now we have from 0 to 1's inclusive, which is actually wrong. Huh. Yeah, because if it's 0, then here, I have to be really careful about this, but it's just, something like this, I think is fine, right? Yeah, I think this is more right. And then, if left minus 1 is greater than equal to 0, then num sub also, and num sub left is equal to 1, then 1's inside, subtract 1, right? So this is just, the idea of, okay, do I have the thing up? Okay. Just to be clear what I was trying to do, because I think I don't have a good way of explaining, or I didn't explain this one that well in terms of while I'm coding anyway. So basically we have, some whatever, right? doesn't really matter. So then here we have, let's say we have 5 1's. So then now we want to start off with the 4 1's, and then so that when we do the first loop, now we have 5 1's. We do the math on. What are you doing? Now we have 5 1's, or 5 things counted, and I keep on tabbing my keyboard. That's why. So now you have the first 5 things, and then now you do the math, right? So okay, so that's basically the idea, really. But it's a little bit wonky to kind of be more precise about it. But yeah, and then now, now we always have enough things inside the window. So then the number of 1's inside the window, well, we want to subtract that from the number of 1's to swap in. So here we can do something like this, right? 1's minus 1's inside. And that's pretty much the idea. And then the only thing is that this is circular, but the good thing is that we take care of left going to 0 to n. So that means that we just have to care about the right side, which the right side is just going to be this mod n, and that should be good. Maybe off by 1 because I don't know, I've just been really bad about off by 1 lately. Yeah. It's the number of zeros inside, right? So why am I'm literally exactly off by 1. All the zeros are grouped already, but I don't. This is so awkward. I don't usually write it this way, so that's why I'm like a little bit messy, to be honest. And I'll rewrite it the other way that is what I'm talking about. But why is that? Okay, well, I guess I should put it out. I mean, definitely should not have -1, so that's no Gucci. Oh, why did I do? Okay, that is just a silly mistake. I mean, that is definitely wrong anyway, but that's the one that goes outside. Okay, and this is the right index. Okay. Okay, so 0 0, that's fine. No, that's not fine. We have 3, so 0 should have 0 1 2. Did I mess this up? Number of 1's is 3. This goes 3 1. So it counts this. Okay. Man, off by 1's are tough. Hopefully this is right. Okay, well, yeah. So that's really basically the idea, though I kind of misread the problem and also did it in a weird way. The way that I actually like to do it, honestly, with these things about dealing with circular array is, especially with circular array and sliding window or some variation of it, is that I actually usually just double the array. So then here, do nums is equal to nums equal to nums. So then now this doubles the number of array. Actually, we do it after counting the 1's, right? So then now what I can do is that now we do for right in range of n. No, it's still for left. Yeah, I mean, I think it doesn't really matter. I mean, you could be really careful about it if you like, but also it just doesn't even really matter in that, yeah. So then now I would write something like if 1's inside on, and then if and then left is equal to right minus 1's, right? So if num sub left is equal to 1, then 1's inside also left is greater than 0, of course, or greater than equal to 0, and this and then if the window is bigger than n or bigger than 1, which means that if right minus left plus 1 is greater than 0. Oh wait, greater than 1's. No, it should be exactly 1's. But Oh, no. It's that, well, left could be negative, that's why. So then you could write it in a different way, but sometimes I write it like this. Then now, that means that the width is big enough. So then now we can do the best is, oh, because I could just do this. What am I doing? Am I off by one? Probably. Let's see. Let's try this one. I think. I write 0, but it should be right? Okay. Maybe today's just not my day still. I don't know why I'm making so many mistakes. But okay. So 0. Oh, I'm being dumb. The way that I rewrote it, I could just I think the n is the different thing, because then now you can just write n as you go to this, and then that should be good. I don't know why I rewrote it in a way such that this works with the new n, because now I'm just only counting the right. But then I just kind of forgot about it. Yeah, so that's basically the way to do it, though I don't know why I took so long. The idea behind this sliding window, the doubling, is that the key observation is that you don't need to go forever, right? You only have to care about the boundary stuff. So we can draw it out real quick. Is that let me find my thingies. If you have something like something like this, say, right? If you double it, then now the sliding window will because what you don't handle is the stuff that goes overlapping the other parts, right? But here, all it does is that, okay, now it takes care of here, it takes care of here, and it takes care of, well, I guess this one is just inside, but you get the idea, right? Is that now, and here, and because you take care of these cases, it should be good enough. That's basically really the idea about doubling the way. That doesn't work all the time, but for some problems, you can identify it. Anyway, yeah, this is, as you can see, linear time, linear constant space. Well, now if you double it, but if you double it, obviously this is actually linear space. But if you kind of saw the way that we did it, then it seems fine. But yeah, and you don't have to double it. You can double it in idea, and then you have something like, well, I guess you just don't write it, and then you can just do mod. Yeah, you could just double it symbolically, right? And then you just do this. And that should be good, I think. Okay, maybe not. Oh, because the new n is mod. Whoops. You have to be a little bit careful. Okay, I guess this is fine, but then we just do it times 2. Yeah, just have to be slightly careful, but as you can see, I don't know why it's slow a little bit. Oh, because of the mod, maybe, I don't know. But yeah, but now this is constant space and linear time, but you can also see the doubling thing. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye.